Welcome everyone, my name is Hossam. In this video I will be reviewing quickly my design proposal for the obstacle avoidance robot project. In this project we are developing a car that can navigate its environment avoiding obstacles on its own using a ultrasonic sensor and 4 motors and at Mega 32 as a microcontroller. As you can see here, this is the full project components. We have that Mega 32 microcontroller, 4 motors for the 4 wheels, 1 button to choose a default rotation direction when the car can move forward because of an obstacle. It will rotate either to the right or to the left. This depends on the default rotation direction set at the start. We have a keypad. We are only using keypad button 1 as a start button and button 2 as an immediate stop button for the car. We also have one ultrasonic sensor which is used to identify the distance of obstacles in front of our robot car. We also have an LCD which has 2 lines, 16 characters on each to visually show the distance and the current car speed and direction. Moving on, this is the system requirements for our project. We're not gonna really get into this because this is just a brief video. We can look at the application state diagram real quick. Here we go. This is the state diagram for our project. Initially the car speed is 0 and we're gonna wait until button 1 is pressed on the keypad. If button 1 is pressed, we're gonna go to the next state, which is the direction setting. We're gonna request from the user to choose a default direction. He actually has 5 seconds to do so. As you can see here, we have a timeout. So initially the default direction is right. Whenever the user presses button 0, the rotation will toggle from right to left, vice versa, until the 5 seconds has passed. Then next the car will wait 2 seconds and then it will start its process. After 2 seconds it will do a distance check and then it will start moving with a certain speed. Depends on the current distance from the next or the obstacle in front of it. We're not gonna go into this so much now. We're just gonna discuss the design layers. For the design layers, we have the microcontroller layer, the MCAL, the HAL layer, and the application layer. This is the common or library layer. I have 4 modules. Timer module, which is used widely in our project. Next we have the DIO module used to control the input-output pins for our microcontroller, which is actually used by the keypad module, the button module, the DC motors, and the LCD. Next we have the external interrupt in the input capture unit, which is software implemented, but it actually uses the timer somehow, so we added it to the MCAL layer. Both the external interrupt and the input capture unit is also used by the ultrasonic sensor that we can see here. And the application layer will control everything underneath it. We also may add another layer in between the HAL and the application layer here. We go into maybe name it the service layer, which contains the robot controller module, which is we have a brief intro or description for this module here, but we really didn't make up our mind whether we will include this or not for this certain project. Um, that's a really quick brief on the design proposal. You can find everything in this documentation on the GitHub repo and also the design files and images. Thank you.